All right, welcome to AP Chemistry. In this lesson, we're going to be going over the units 1.1 through 1.3, and we're going to be looking at questions 4, 5, and 6. And that goes over this section 1.1.8.2, and we're going to show Avogadro's number. It provides the connection between the number of moles in a pure sample of a substance and the number of constituent particles or formula units of that substance. All right, and so understanding the mole concept, remember that a mole is representing a number no different than dozen means 12. Mole means 6.02 times 10 to the 23rd. Also can be called Avogadro's number. And so moles and the number of particles is the most direct application of Avogadro's number. For example, if you know there are 2 moles of water, you can multiply Avogadro's number to find out how many molecules of water you have. And that goes into looking at representative particles and that type of thing. If we look at a mole of water, and we can represent that in terms of the number of molecules, because water is a molecule. If we looked at a mole of carbon atoms, we'd have to say that it's the number of atoms, because the representative particles atoms, and that so on and so forth. And the same thing with a formula unit, which would mean an ionic compound. But let's go ahead and look at question number 4, and we'll maybe hit some of those ideas as we go through these. So relating the moles to the number of atoms for a pure element, says how many atoms are in 3.2 moles of carbon. And so what we'll do here is we'll start with a given 3.2 moles, MOL of carbon. And then all we're going to then do is use our periodic table to convert from moles to atoms. We want to know how many atoms. So we know that in carbon, 12.01 grams. So that's what we're looking for, 12.01 grams. Oh, we'll say 1 mole. Well, actually, we don't even need to know that. 1 mole of carbon, this is not the mass, I'm sorry. 1 mole of carbon is equal to 6.02 times 10 to the 23rd atoms. If we weren't given grams, we were given moles. So 6.02 times 10 to the 23rd atoms of carbon. All right, and so that's all we have to do. Really easy. 1 mole is equal to that number. And so all we have to do is put that into our handy dandy calculator. We'll make sure we do that real quick. So we got 3.2 and then times, and I put this in parentheses, 6.02 times 10 to the 23rd. And then we see that it is 1.9624, 1.9264 times 10 to the 24th. So we'll copy that. And then we can go back into add math, click on that, and then hit boom. And there we go. And we can have 2 sig figs. So this is going to be 1.9 times 10 to the 24 atoms of carbon. So we want that as our answer. So we control C, save, place that in here, and this thing is over. We're done with this question. Question number 4 is in the books. And that is just simply relating moles to the number of atoms. The pure element is carbon. So 1 mole is this many atoms. 1 mole is this many of anything. And that's the point here. In this case, when we're talking about an element, the representative particle for an element is an atom. The representative particle for a molecule is molecule, and the representative particle for an ionic compound is the formula unit. And so that handles question number 4. Question number 5, it says relating moles to the number of molecules. Again, here the representative particle, this is water. Water is a molecule. Note it's made up of only nonmetals. So the representative particle is molecule. And we would not say we have so many atoms of water, because water is not an atom. We don't find water on the periodic table. We can find hydrogen and we can find oxygen, but water is a molecular compound, and so we have to refer to it correctly as a molecule. All right, so how many molecules are there in 0.75 moles of water? So we'll start again, 0.75 moles of H2O. And just so we know how to write that, we can capital H, this is shift dash, it's the number, that's the button right next to 0, 2, and then if you hit the over arrow, that brings that back up, O, and then that's all we do. Multiply bring your fraction in here, and we know that 1 mole of H2O, and let's say you don't want to type H2O over and over again, just simply copy that and then paste it right next to it, and then Control V. Control V. And there we go. 1 mole is equal to 6.02 times 10 to the 23rd. And then we're going to say molecules, because that's the representative particle of H2O. And there we go. And all we have to do is plug that into our handy dandy calculator. And we have a lot of that in there already, because we are simply multiplying by Avogadro's number. Here we said 3.2. We'll just put in 0.75. And now we have a different number, 4.515 times 10 to the 23rd. So we'll go ahead and place that as our answer. Control V. And we should have 2 sig figs, so 4.5 times 10 to the 23rd. And this will be molecules of H2O. All right. 4.5 times 10 to the 23rd molecules of H2O. And then make sure we put that in the response box. So we don't want to type that again. So Control C, save. Come over here, Control V, done. And hopefully you're getting your points. All right, we'll move over to the next one. It says relating moles to the number of ions in a pure ionic compound. Okay, so now we look at water in a molecule, sodium chloride being an ionic compound. An ionic compound has a representative particle called the formula unit. So we want to know how many chloride ions are in this. And this time we're worried about chloride ions, not just the number of formula units, but the number of chloride ions. So we're going to start off with 0.64 moles of NaCl. Again, we can relate this, but we could say 1 mole of NaCl is equal to Avogadro's number of formula units of NaCl, but we're not interested in that, trying to find chloride ions. So what we're going to say is 1 mole of NaCl is equal, if we look at the formula, 1 mole of NaCl is equal to 1 mole of Cl, and it's the chloride ion has a minus charge, 1 minus, and you can put minus or 1 minus, and then now we can say 1 mole of chloride ions is equal to Avogadro's number of chloride ions, 6.02 times 10 to the 23rd, 23rd chloride ions. And I could write ions, but because I am showing that charge on there, we recognize that it is an ion. And so here again, even though this is a 1-to-1 ratio, we still need to show this part because if it were magnesium chloride, it would be MgCl2, and 1 mole of magnesium chloride would equal 2 moles of chloride. And so that would change this whole calculation. So just because it's 1-to-1, you can't just ignore it. We have to show that step, make sure you know how that works, because not all the times is it going to be 1-to-1. All right, so let's change this up. We see 0.64 times 6.02 times 10 to the 23. So I already have this in my calculator. Let's not make it hard on ourselves. And then we end up with this value here. And we see right here, Control V. And then we're going to have 2 sig figs, 3.9 times 10 to the 23rd. And then we see Cl, and then minus or 1 minus. They will all work. Yeah, so all of that will work. And then just make sure we copy this and paste it into the response box so we get credit. So we are done there. So in this video, we went over questions 4 through 6. I hope that helped. That should be very easy, quick calculations relative to the first 3. And then we'll move on through 7 through 10 in the next set. Thank you for watching. Please like and subscribe.